Good morning, class. In the second episode of CFT, we are going to deal with the properties of complex by CFT. In these properties, we have to discuss three of the main properties, that is high spin state and low spin state. Number two is magnetism, and number three is the color of the complex. The question arrives when a complex is said to be having a high spin state and when it is said to have a low spin state. For that, we have to remember these terminology. That is, when the ligand is strong, it will be having low spin state, and when the ligand is weak, it will be having high spin state. Okay, now we come to know when high spin state and low spin state will exist. But what matter if a complex is said to be high spin state and when it is said to be the low spin state? High spin state and low spin state affects the electronic arrangement in their orbitals. As in high spin state, firstly single filling in each and every orbital of d do occur, then only pairing will occur. Meanwhile, in low spin state, firstly the lower d orbital will be filled, then only the higher d orbital will be filled. That is, if we are considering an electronic configuration to be the d4, and if the complex is said to have a high spin state, as single filling will be there, that means firstly 1, 2 and 3 electrons will be filled in T2G orbital, that's the lower orbital, and the fourth electron will be filled in EG orbital. As I do have total of 4 electrons, the filling will be like this in case of high spin state. Meanwhile, in case of low spin state, firstly the lower orbitals will be filled completely. Once they are being completely filled, then only the EG orbital will be filled. That is, if I had to fill the 4 electrons, the filling will be like this, 1, 2 and 3, and the fourth electron will be over here. Okay? Now, similarly, if I do have one more configuration written over here, say as if I do have the D6 configuration, in case of the high spin state, as a single filling is being masked, so the filling will be like this, that is 1, 2, 3, then 4 and 5, sixth will again lies there in the T2G orbital. Similarly, in case of low spin state, firstly the lower orbitals of T2G will be filled like this, 1, 2 and 3, then 4, 5 and 6th orbital will be filled, and as EG orbital does not have as I don't have much of the electrons, so the EG orbital will not be filled. Okay, that means strong ligand and weak ligand do affect the filling of electrons in the orbitals of d. Okay, the second terminology which we are going to deal is the magnetism. That means if we do have all the electrons to be a paired one, then the magnetism comes out to what? Diamagnetic. Meanwhile, in case of unpaired electron, the magnetism will be paramagnetic. As I had already told to you that in case of VBT also we have been discussing that P में कभी P नहीं होगा, that is paired electrons, it will be having diamagnetism, and in case of unpaired electrons it will be having paramagnetism. Okay guys, we are moving towards the third terminology, that is color of the complex. Say as if I do have a complex over here, coordination compound over here, that is TiH2O whole 6 plus. It has been seen that when this compound is being heated, it do impart a color. Okay, so it has been remarkable that if a compound which do have unpaired electrons in the d orbital, when they are being heated, it do undergo dd transition, and because of which they do impart color. That is, in 11th standard also we came to know that when the electrons they are in the lower orbital, this is the lower energy level or the ground state, when heat has been absorbed by this electron, they get excited and move towards the higher orbital, that is higher energy level. But when they reach over there, they releases energy and come back to the ground state. But if this released energy lies in visible spectrum region, then the compound will impart the color. That is the basic funda behind the color of the complex. But as in this complex, we can see that titanium do have an atomic number of 22. So the configuration turns out to what? D3D2 4s2. But when we calculate the oxidation number of Ti, it comes out to Ti3+. That means 3 electrons should be removed. two from this s orbital and one from this d orbital. So the electronic configuration of Ti3 plus comes out to 3d1. As this one electron which lies in T2g orbital, when absorbs energy, get excited and move towards a higher energy level. And when it comes back to lower energy level, it do releases energy, and as this energy lies in visible spectrum region, so it do impart color. Okay, guys, with this, we had winded up the three of the main properties of the D block of the coordination compound. Now we are moving further to see the crystal field splitting in octahedral and tetrahedral complex. Guys, when a complex is said to have an octahedral arrangement, in this condition, if we had a coordination compound, we know that in a coordination compound, we do require two of the main component, that is metal and ligand. If I do have a metal which has been surrounded by 6 ligand, then the structure of that particular coordination compound turns out to be the octahedral one. In this octahedral complex, when d orbitals are being arranged, before the attack of ligand, this d orbital do have equal energy, so are said to be the degenerate orbital. With the attack of ligand, this degeneracy splits, and three of the orbital, that is dxy, dyz and dxz, is said to be the T2g, will lie at the bottom, and dx square minus y square and dz square will lie at the top, termed as Eg orbital. The difference between these two energy orbitals are being termed as crystal field splitting energy and is being represented by delta O. The central line over here is being termed as barycenter. The distance from the energy gap from barycenter to that of Eg is being represented by 3 by 5 O, and from barycenter to T2g is being represented by 2 by 5 O. Okay. Similarly, in case of a tetrahedral complex, when the ligand, when a metal is being surrounded by 4 ligand, then the complex is said to either tetrahedral or square planar. In case of tetrahedral complex, when before the attack of the ligand, the d orbital do have equal energy, but with the attack of ligand, this degeneracy split. In case of tetrahedral complex, the Eg will lie at the bottom and T2g will lie at the top. The gap over here is again termed as barycenter. Similarly, from same that of octahedral complex, the difference between T2g, the energy difference between T2g and Eg is being termed as crystal field splitting energy. In case of tetrahedral complex, it's been represented by delta T. The energy gap from barycenter to Eg is been represented by 3 by 5 T, and from barycenter to T2g is been represented by 2 by 5 T. Okay, one of the important board questions which has been asked several times in the board is that say as if a structure, if a coordination compound do have the if in an octahedral complex, if delta O values is greater than that of pairing energy and the electronic configuration is said to be D4, how the electron filling will be there. Similarly, in case of D4 electronic configuration itself, if a complex do have greater pairing energy than that of delta O, which type of electronic configuration will be there? It is remarkable that when delta O value is greater as compared to that of pairing ligand, strong field ligand will be there, and in that condition, firstly lower orbitals will be filled completely, then only the pairing, then only the higher orbitals will be filled. That is, if I do have D4 configuration, the configuration comes out to what? T2G4 and Eg will be 0. Meanwhile, in case of weak field ligand, when the pairing energy, where the pairing energy is greater than that of octahedral complex, firstly single filling will be there, then only pairing will occur. That is, in T2G, 3 electrons will be arranged and the 4th electron will move towards the Eg orbital, as I had already represented there in diagrammatic manner in the property zone. Okay, I hope this portion is being clear to you all, including the properties and including the board examination, board question. So we will be meeting there in the next episode with Vehana theory. Till then, bye bye.